All right, let's have a look at some information here on pipes. A lot of what we're talking about in this class is storm drain and water and sewer pipes. So let's look at the different types of pipes that are used. In the current edition of the book I have, this is on page 12 is where it starts. So a lot of different pipe types are used. Let's look at what they are and what they're used for. So the first type I'd talk about is gray cast iron. Okay, it's obviously made of cast iron and it's gray in color. So the advantages of gray cast iron are it's strong and durable. It has a very long life. There's some of this stuff that's been in the ground for 100 years or more now. It was, I think, first used around the early 1900s. Now, there are disadvantages. It's quite heavy. It's also cast iron, so it's brittle. If you can shatter it, actually, if you strike it hard on something or hit it hard with rock or something like that. It corrodes and it's expensive. Okay, it was used for water mains. It's now obsolete. It's been replaced by something called ductile iron pipe, which is another type of iron pipe that's makes some improvements on some of the disadvantages of gray cast iron. So you might still run into this stuff because it's so durable and lasts such a long time. But nowadays, if you're going to put iron pipe in the ground, it's most likely ductile iron. Now, ductile iron looks different. It's a black color. It's got a mortar lining, which makes it smoother on the inside for better hydraulic capacity there. It has it's a smoother pipe, so you can get more flow through it. It's also got a bituminous, which is kind of a tar coating on it to resist corrosion. So that's some of the improvements. So the advantages of ductile iron is it's more ductile, which means flexible than gray cast iron. Now, it's not really flexible, but it's more flexible than gray cast. It's not brittle as much as gray cast iron is. It's strong, durable, and it's smoother than gray cast iron, which means you can get more flow through a certain size. Disadvantages, it's heavy and quite expensive. It's used for water mains. Okay, it has iron, but its magnesium is added to the iron to make it into an alloy, which gives it the ductility. It's very commonly used today. Okay, so this is one of the main types of pipes used today, primarily used for water pipe. Stainless steel is also used in some applications. It's corrosion resistant, strong, and it can be welded into different shapes. The disadvantages are it's expensive and heavy, and it needs to be welded, which is a very difficult way to join pipe together. It's used for bridge crossings because you need to have the pipe have its own structural strength on a bridge crossing, so you can weld it into one continuous pipe for the length of the bridge. So anytime you have to cross a river or something like that, and you go up and over a bridge to do it, this is a common type of pipe that might be used for that. I think it's also used in pipe galleries and water plants. But it's not used in many other applications. Okay, so it's used for those types of things. Okay, there's also another type of steel pipe that's called OD steel, which means outer diameter. What that means is an 8-inch OD steel pipe has an outer diameter of 8 inches, as opposed to the inner diameter being 8 inches. So that's why it's called OD steel. It corrodes a good bit. It was used for water pipe. It's obsolete, but you still might find some of this in the ground if you're working for a city. Okay, concrete is another type of pipe that's very commonly used. It's strong and can be worked so it's quite smooth on the inside, so that makes for a good hydraulic characteristics. It's very heavy, it's expensive, and it's hard to join. Also, it can be corroded by acidic water too, which can be a real problem. Now, this is used as certain applications. It's used for large diameter sewer mains. If you put a sleeve in it, a steel sleeve that'll make it contain pressure, it is used for large diameter water mains. It's also used for lines that are not buried very deep, so they need more strength. When you put a line of some type of pipe under the ground, usually you have to have something like 3 feet of cover on it. Dirt above it is what cover is, to protect it from the loads from the street above. So trucks and cars and things like that will load the pipe and can make it deform or break. So you put at least 3 feet, roughly let's say 3 feet of fill above the pipe to protect it from those loads. Now sometimes due to the grades you're building pipes at, you can't get that 3 feet of cover. If that's the case, this can be a type of pipe you can use that's quite strong and may not require the full 3 feet of recommended cover. So that's another use for this pipe. It's also used for culverts too. I guess that should be added to that list of uses. So culverts is a common use for this. A culvert is a pipe that crosses a street or a driveway or something like that, that runs usually from a ditch to continue a ditch under a driveway, or to continue a ditch or a stream or something like that under a road. Okay. Now something like concrete, but not quite the same as asbestos cement pipe, which is called AC or transite. Now this certainly is no longer used, but it was, and you still might encounter this under the ground, so you should know about this. The advantages are it's lighter than concrete pipe and it's quite smooth. Now, of course, there's some huge disadvantages to this, and that is that asbestos is a carcinogen when it's breathed in. Okay, so the health effects of asbestos are very extreme. So you want to be extremely careful around this type of pipe. If you are not trained to do it, you would never want to cut this pipe or work with it. Okay, people that are trained to work with it and have the proper personal protective gear, including a respirator and a Tyvek suit and things like that, if they're trained, they can work with it. They might use a saw that's a wet saw to keep the dust down, but again, they have to be trained to do that. This stuff can cause cancer. It's just not something that you want to work with unless you know exactly what you're doing and you have the proper equipment to do it. So that's the airborne concerns when you get this, when you cut asbestos especially, you can get that dust up in the air and the fibers can get into your lungs. But it's also a waterborne concern too. So if you have somewhat acidic water, it can attack the concrete in this pipe and release the asbestos fibers, which people can then drink. That's another concern with this type of pipe. Okay, so the health effects of this pipe are very, very bad. It also had poor production quality, so it had diameter variations, so it could be hard to join. Brittle, it can be corroded by acidic type water too. It was used for water mains and just any other pipes. Certainly not used today anymore, but you might encounter this, so just be aware of it and be very aware that you should be trained to deal with this properly if you run into it, if you're working for a city. Okay, another type of pipe is corrugated metal pipe. It's corrugated because it has those arches kind of formed into it, which give it strength. Okay, it's light. Even though it has those arches that are kind of integrated right into it, you can see that kind of arch pattern right in there, those ribs there. It's still not as strong as some of these other types of pipes. It can corrode too. It's used for culverts, and culverts are pipes that, again, that cross under a driveway or cross under a road. They continue a ditch from one side of the driveway or road to the other, or a stream from one side of the road to the other, and allow the water to flow under a road. You do see this stuff a lot on Forest Service roads and BLM type land too. Up in the woods, you might find this used for culverts quite a bit. It doesn't seem to be used around town quite as much. Right, there's a lot of plastic pipe. PVC, polyvinyl chloride, is a very common type of plastic pipe. It's very smooth, so it has very good hydraulic characteristics. It's also light and easy to handle, which is another real advantage over, let's say, an iron or a concrete pipe. The disadvantages are it's not super strong, especially when it gets cold. It can get kind of brittle. It also, I've heard some concerns that it might be chemically reactive with water, which may not be a good thing, that stuff can leach out of it, I think might be the best way to put that. I've not seen any research on that, but I have heard concerns about that. It's used a lot for water and sewer lines, so this stuff is very commonly used. Okay, the stuff that's used for water is designated C900, which is a high-strength, thick-walled PVC pipe. There's some of it. It's usually this light blue color, normally what it is. It's light and smooth. Again, the disadvantages are the strength, and also the concern that it might leach chemicals out over time. You can see if it's been in the sun, it kind of gets that white color that you're seeing there, so it does react with sunlight if it's been sitting out in the yard for a long time, and it loses its strength, I believe, when that happens. It's used for water mains, very commonly used today. Now it's also, PVC is also used for sanitary sewer and storm drain. It's a slightly different type of PVC pipe, but it's used for water and storm drain also. It's ASTM 3034. This is the type of pipe that's used for sanitary sewer and storm drain. Okay. So sanitary sewer and storm drain. It's green. It's a thinner walled pipe than the C900. So the C900 is thicker walled and blue for water. The sanitary sewer and storm drain pipe is thinner walled and it's green. Again, it's light and smooth. There might be some concerns about the strength of this, but this is the most common type of sanitary sewer and storm drain pipe that's used today, because it's just so light and easy to handle, which is a big concern when you're joining pipe in a trench underground. Okay. Another type of plastic pipe is ADS. This is a black ribbed pipe. You can kind of see those ribs there. Quite often it has a yellow line running through it. Okay, it's light and smooth. The disadvantage is, again, not the strongest pipe. I've seen this used for storm drain main. It's often not approved for use under a street, okay, because of the strength concerns. Sometimes they'll, on the bigger diameters of this stuff, they'll put a smooth inner sleeve so the water has a nice smooth path to run through. Not always, but I've seen that used. I've also seen this used for perforated pipe that is actually designed to get flow to flow into it. Okay, has holes punched in it and buried that's used to drain wet soil and things like that. Okay. Another type of plastic pipe is HDPE, which is a high density polyethylene. Looks something like that. Here's some people putting this in. So this stuff comes on a big spool. It's a long continuous spooled pipe. It's a little flexible too. So here they're kind of pushing it under the ground or pulling it. They're not doing a full excavation here. They're using this and running it through the ground from one point to another to avoid having to dig a big trench. That's a common use for it. It's light and smooth. It's strong. It can be laid in a curve is one advantage to this stuff. So it's kind of flexible. So it can be run around a curve. I don't really know enough about this yet. It's still fairly new, so I don't really know the disadvantages of it. It's used for natural gas. It can be used for water, though I'm not seeing it approved in a lot of places in this country yet for water, but eventually it might be. It's welded, okay? So you make a welded joint there, use heat to weld it together to make the joints on this stuff. Okay, now all of these plastic pipes, one concern of is locating them when they're underground. So sometimes they'll run a tracer wire along the length of the pipe, which would just be a copper wire. I think they're copper anyway, that's run along the length of the pipe, and it's a metal. Obviously, it's a metal wire, so it's easier to locate than just plastic pipe would be. So that is one thing that is sometimes done when you lay plastic pipe, is you also put a tracer wire in there so you can find it after you've buried it. Okay, clay pipe, kind of a vitreous clay, which is baked at a high temperature, very weak. Has been used for sanitary sewer and drain fields and things like that. It's old and obsolete. It's not something you'd use any longer. There was also another very old type of pipe from a long, long time ago, made out of wood staves. They essentially just made a long barrel out of wood, and then they coat it, I think, in creosote and wrap a wire around it to hold it together. When it got wet, the wood would kind of expand out and help seal the joints. Not many advantages to this stuff. I mean, it's pretty cool how they built it and all that, but other than that, no advantages. It leaks. It's hard to join. You don't get real consistent outer diameters with it. So, that's some of the disadvantages. It was used for water pipe and miscellaneous pipe. It's old and obsolete. There still might be some in the ground that's in service. I don't know. As time passes, of course, there's less and less of it out there. It is amazing just how hard people work to build this stuff. I mean, this is essentially built like a barrel. It's got some tongue and groove type joints on each of these individual pieces of wood that are joined together to make that pipe. So, awful lot of labor went into that. There used to be a manufacturer in Oregon that made this stuff for gutters and things like that, just because it looks so cool. All right, now these are mains here. These are large diameter pipes that I've gone over. Let's say at least 4 inches, typically 8, 12 inches or larger. Those are referred to as mains. So that's what we've covered here so far, okay? The large diameter pipes that carry a lot of water. Now you also then, when you put mains in, you have to run a line from the main to the customer, and that's done with something called a service. These are typically smaller pipes, okay? That run from the main to the customer. Okay, now water services, copper is probably the most common right now. It's strong and smooth, it bends. You can get copper that dissolves into the water and causes health problems. That's a problem. This stuff can kink a little bit if you bend it wrong too. It's used for water. Now here you'll see kind of the typical copper like you might have inside your house. This really isn't what we use in public works. In public works, we use what's called type K copper, which is more flexible. Okay, so a little different than what you're seeing down there. And this stuff is flexible and laid out in rolls. Is used for water services. So that gets the water from the main to the meter, basically, is what it does. Okay, they can also use PVC pipe. It's cheap and smooth, and not the strongest. It's glued together with those sleeves. It's used for water. It's still fairly commonly used today. Okay, that and copper are the two common water services that are used. Okay. Sewer services are bigger than water. Water services typically around 1 inch in diameter or so for a house. They might be a little bit bigger for a large business. But sewer services, which take the wastewater from your house back to the sewer, they're usually about 4-inch diameter, so they're bigger. They just use smaller PVC SDR 3035 type pipe, this green pipe. Instead of being an 8-inch like a main would be, they're like 4-inch. So same advantages. It's cheap and smooth and light, I guess I should say also, and so easy to, and it's easy to put together. The disadvantages are the strength. Okay, so I guess I could add that it's light here too. It's used for sewer. It's very commonly used today. Okay, there's some other types of pipe we could mention here. Polybutylene is this black pipe here. It's kind of flexible black plastic polybutylene pipe. It's smooth, but it kinks very easily. Just not very well regarded stuff. It was used for water services. It's not used anymore that I know about. In the past it was, but not any longer. Galvanized pipe is galvanized iron. Okay, it's kind of straight pipes of iron. It was threaded, so it has threaded connections. Not well regarded at all. This stuff is old and obsolete. It's not used anymore because it corrodes so badly. You get these large kind of rusted corrosion nodules inside the pipe. It's hard to join too, so not a very good pipe. Okay. It was used for water services. You might have some if you have an older house inside your house. It's very difficult to work with because when it corrodes, it really starts to be difficult to do much with. All right, so that's some of the different pipe types that we commonly use. So keep in mind the difference between the mains, which are the large diameter pipes here, this sort of thing, and then the services, which are the smaller diameter pipes. So the mains go under the street. They carry the large amount of water around the city. The services take the water from the mains to the houses or businesses or whatever. Okay. All right, you need to join these pipes, and these underground pipes like we use, they're joined differently than plumbers join pipes. We're not talking about plumbing here, we're talking about public works, so it's a whole different system. So the vast majority of joints for these underground mains are push-on joints. So they have a plain end that pushes into a bell end. The bell end has a gasket, so here's the plain end of pipe, here's the bell end. The bell end has a gasket in there that can be lubricated to make this joint come together, but then that gasket is formed so that you can't pull the pipe out very easily once you've put it in. Okay, and this is the joint that's used in 90% plus of the pipe underground because it's easy to put together. See, these large, what are called sticks of pipe, large lengths of pipe, can be 13 feet, 20 feet long. They're heavy. You're in a trench joining these things. It's hard to do. So typically they want to make these joints easy to put together, and a push-on is the easiest type of joint to put together. It can be deflected a little bit, as you see there. It's easy to assemble. Okay, so it's used for sanitary, storm drain, and water. All these main utilities use this type of joint. It can be deflected a little bit. As you see there, it's easy to assemble. It isn't the strongest joint, but it's a everyday common joint. 90% plus of the joints underground are push-ons. Okay? Now, if you need more strength, the next step up is called, or the strongest joint is called a flange. You have these flanges that usually are just integrated into the pipe, the stick of pipe as we call it. So that would be formed right into the pipe. You can then line the two flanges up, put a gasket between and bolt them together. Okay, it's the strongest joint, but it's totally rigid. It's very hard to assemble too. Okay, you can imagine being in a trench with a 20-foot long ductile iron pipe with a flange on it. You know, it's going to be really hard to turn that and align it with the other flange pipe to get that to work. That's going to be difficult to do and hard work. So, you know, that's a disadvantage of this type of joint. They're used on water lines, force mains too, for sewer, because they're pressurized sometimes. And you want to have that, if you need high strength, you might go with a flange, but typically what they're really used for are fittings, T's, Y's, valves, things like that, smaller fittings that you can work around and get to line up properly so you can flange them. Okay, that's the typical use of them. Now, something in between those two types of joints is a mechanical joint. Here you see a plain end of pipe, you fit a tight gasket on there, and then a slidable flange type device here that isn't connected to the pipe. It slides. Okay, you can then put that plain end of pipe into this bell fitting here and then push this slidable fitting here up against the bolt holes and bolt that up. When you do, this little extension here will compress that gasket and get you a good strong connection. This is called a mechanical joint. It's not as strong as a flange, but it's an awful lot easier to put together because you can slide this connection on the pipe. Okay, it's used on water lines and also force mains when moderate strength is needed. And this can be a transition from a flange joint to a push-on joint on a line. Okay, the pipes can be deflected. You can also reinforce these mechanical joints and make them quite strong. There's different ways of doing that. Okay, so here's a push-on ductile iron connection right there. And then here's a mechanical joint. Here's that slidable flange device. There's the gasket. And then there's the bell end. All right, now if you're putting a T in on a water line, which is very common to do, there's different ways of making that connection, but here's a common way to do it. There's many ways to do it, but here's one way it's done. They use an all flange T, meaning they've got a T with a flange on every side, okay? So that's T has 3 flanges on it. Then the fittings are flanged by MJ. So we've got 2 gate valves on this T. Those gate valves have a flange on this side, so that's a flange, but then they have a mechanical joint on the other. So what these valves are doing is they're transitioning from a flange on this side that can be bolted to the T, and then they go to a mechanical joint on the other side. And then what you can do then is do the bolting on these fittings, which are fairly easy to rotate and work around in a trench. But then when you bring the long pipes in, they're just plain end pipes, and they fit in to that mechanical joint, and then you can bolt up that slidable fitting there, compress the gasket, and off you go. So this is a common way of doing a T connection, okay? Because you've got the more difficult connections, the flanges and MJs on fittings that are small and fairly light and can be rotated and put together fairly easily. Then you've got the plain end on the pipes that can be fit in there. Okay. Here's a connection that seems to have quite a few things going on with it. There's a flange connection. See how they're bolting. See, that's integrated into the fitting and the T there. That's a reducer actually. And then here's another flange. This one's a mechanical joint right here. You can see how that is a slidable fitting right there that you can slide up and compress the gasket with. This also has these kind of set screws where they're putting screws in that bite into the pipe and make for a stronger fitting. That is a little bit unusual to use those with a plastic pipe. That looks to be that C900 here. That's a little unusual to use a set screw like that on a plastic pipe because you could break it, but you know, hard to say there. They might have just put that together just to show how they're doing it. I don't know. Okay, so that's a mechanical joint there. So that's how those fittings are being used. You also see some reducers there that look to be flange by flange, and then they're going to the valves after that. So that's how they're doing this connection. You know, it just depends on the situation. All right, there's other connections that are used. There's sleeves that are glued in PVC or threaded and galvanized. So there's a sleeve that fits over the pipe that can be glued in or threaded. You can weld connections together. Stainless steel is welded using conventional welding. Special type of welding rod for stainless. I don't know welding well enough to know what it is, but you do have to choose the proper rod for that. And then the HDPE, this plastic pipe, is actually heat welded. That's how that's joined. Now, services for water have compression and flare fittings. So this side here would screw in either into the main or into a saddle that fits around the main. Then to get to the service pipe, you can either put this connection over the pipe, then flare the pipe, butt it up here, and then screw it down with some pipe sealant. That'll get that to be a nice strong connection there. Okay, so there's a couple flare connections. So you put that bell fitting on the service pipe first, then you flare the pipe at the end, push it up, and then screw that on, and that'll get you a nice strong connection there. Here's a little bit less strong of a connection called a compression fitting. That's a similar kind of deal here. You put that on, you then push the service pipe into this valve here, and then you tighten this up. And what that does is pushes on a thick rubber gasket and makes that gasket kind of bulge out, and that actually holds the pipe in there. So there's some fittings on service lines. Okay, another little thing here on pipes is you have to be concerned with the wall thickness of pipes. So these are called out in a number of different systems. For ductile iron pipe, they're class, they're called. Typically, ductile iron pipe is somewhere around a class 52, but they range from 50 to 60. The bigger the number, the thicker the pipe wall. PVC C900 and asbestos cement were based on working pressure, so they were pressure rated. That's how they describe their wall thickness. Standard PVC has what they call Schedule 40, Schedule 80, or typical schedules that refers again to the strength of the pipe and the wall thickness. Now, typically when you change the wall thickness, you want to hold the outer diameter constant. That way you can join two pipes together easily. So the wall thickness typically comes out of the inside of the pipe. So if these are two ductile iron pipes that are different classes, so they're going to have different wall thicknesses, what you want to do is hold this outer diameter constant. That way you can fit the two pipes together. So if you want this pipe to be thicker walled, it's going to have a smaller inner diameter, so it'll carry less water, but be stronger. That's the idea there. Okay, so that's just a little bit of information there on pipes that are commonly used in public works utilities.